1997 Toyota 4Runner, beautiful looking truck all the way around, very well maintained, just a beautiful truck. Problem with it is that the battery will go dead after 2 or 3 weeks. So the owner of this truck leaves for work, and he would leave truck on a driveway, wouldn't drive it for 2 or 3 weeks, and when he comes back home and sit in the truck, the battery is completely discharged. It's completely dead. He did replace the battery, and problems happen again. Now, if you drive the truck every day, everything's fine. But in his case, he has to leave it for a couple of weeks, and then it's a problem. By the time you come back, the battery is completely drained. Now, this would be a good case study for a thermal imaging camera, which I don't have it. I'm planning to get one sometimes in the future, but they're just too expensive. So I'll show you guys what I found. And also you can see here there are a whole bunch of extra, these extra lights and all that. So let's see what the problem was. Okay, as you can see, this car has a custom lights. Now, he told me the problem was on this car was before they installed these custom headlights and stuff. And this is, as you can see, the very low current draw that would kill the battery in a couple of weeks. As I said, if you drive the car every day, absolutely no problem at all. Now, before you start doing this, you wanna open the. There's another set of fuses inside the car, so you wanna open the door and flip the switch, the door switch. The computer actually goes to sleep. This car, actually, the door switch is on the door jamb itself. So you just take some kind of clamp and clamp that switch so that all the motors are going to sleep. And now for this car, it doesn't take long to go to sleep, maybe 5 to 10 minutes. It's an older car. And so the next step is to, look. Now on some cars also you might actually have a sensor for the hood, and you want to make sure that switch is closed as well, because the car will not go to sleep if the hood is open. And it's not the case on this car. So anyhow, the next step is to attach our M clamp to positive or negative cable on the battery. Now for that job I'm going to use this UT210E. This is a current clamp. This is an AC and DC clamp. I'm pretty impressed with this little tool. It's very inexpensive, around $40. I got it out of I ordered it straight from China. And the nice thing about this tool, so it's AC and DC current. You can measure both, but you have a setting for 2 amps, and this is you can measure very low current. Now, in order to use it, you're going to press this blue button, and it's going to switch to AC to DC mode. Okay, and then you're going to, by pressing the black button, you will zero your tool, and you're ready to do your measurements. Alright, so the first thing we're going to do, we're going to set the tool on our negative cable. And as we can see, we have a draw of around 200 milliamps. Okay, so that is too much anyway, but as you drive the car, I'm not sure if you guys can see it or not, but if it has to be, it's a 200 milliamps. Okay, now if you this is too much anyway. It should be more below 100 anyway, but if you drive the car every day, this is not going to cause a lot of problems. So the next step is to find a circuit that causes our issue. And my favorite, so basically you can start pulling these fuses one by one until the draw drops down to 0, or drops to acceptable level, maybe 50 milliamps. And another way we can do it, we can measure a voltage drop across each of these fuses. And if you measure any kind of voltage drop, that's indicate that current is actually that's closed loop, and there is a current going through that circuit. Once we isolate our circuit, then we go to the wiring diagram, and we'll see what loads are on that circuit, and we have to go to each of the loads to see which one is shorted, which one causes a draw. Now, when we're measuring the voltage drop across these fuses, that's going to be a very, very, very low voltage drop. We're talking about a couple millivolts, but it has to be total 0. Cannot be any kind of voltage drop at all. So this is just a, see now I'm going to actually set my tool to a milliamp mode, okay, and I go to DC, and now we can see actually as we have our leads out of the circuit, you're going to have some kind of reading on the tool. Now if I connect my leads, we have zero. There has to be absolute zero, cannot be any changes on it. So what I'm going to do now, I'm going to go from one fuse to another, and you guys will see there's absolute zero on this one. Go to this one, we got zero. Go to this one, we got zero. So pretty much all of these fuses, other than this one here, this is a 15 amp fuse, and it used to have a 0.1. So this is a live circuit. There's a current going through this fuse, and something's going on this circuit. And no matter what I do, whichever way I set my leads to this fuse, it reads a draw. So now the next step is to pull this fuse and see if this draw on our amp meter drops down. So we are still reading around 200 milliamps. I'm going to grab the pliers and we're going to pull this fuse. Alright, I'm going to pull the fuse out, and it dropped down to 180 milliamps, which is a live circuit, but it's not the one that's causing the draw. So this is what like 20, 30 something. Now actually it's interesting. So this is a problem also. When you start pulling the fuses, you can see for the moment we had actually half an amp. It's a 500 milliamps of a current, and right now we have a 378. So problem with the pulling the fuses is that every time you do it, you're going to wake up some of the modules, and then everything goes alive again, and then you have to wait again. So measuring a voltage drop across the fuse, it's the best way to do it. And right now we have a 378. I'm not sure if you guys can see that. Let me get the camera a little closer. Yeah, right there we can see we still have a 367. Now it just, yeah, it's still fluctuated. So anyhow, something else woke up. But this is a problem? No, it's not. It's just the fact that by pulling the fuses out, we had disturbed the system, and something else is awake, and it will take a while for this to drop down to 200 milliamps, where we actually have actual draw. So now this got me on the wild goose chase. I have checked each relay. I pulled each relay. I pulled, checked the voltage drop on each of the fuses, and check the alternator, check all the fuses in a car. There was absolutely no draw anywhere other than this fuse, and this 15 amp fuse actually was a dome light, and something else is attached to the circuit, but that's not my problem. Something else is going on. So what do we go next? I mean, we absolutely have no way of finding this draw. It's not in the fuse box, and all the circuits that all the circuits are going through the fuse boxes. It should be there. Unfortunately, on this car, it's not. So I said, well, let's start digging some deeper and see what I can do. And so I can see right now we have two ground wires here. There's a smaller ground wire and a thicker ground wire. Okay, so what I did next, I got my M clamp and I put it on the bigger wire. Zero it again, and we have 140 milliamps. Now and I have to wait now for the car to go to sleep, but once it goes to sleep, there's actually no current going through this thick wire at all. I may just have to stop the video, and since I pulled that fuse, some of the modules woke up, so let's just wait a little bit, and you'll have to come back. Now let's go ahead and check this wire here. I had 190 milliamps of current. Okay, so 180, 190. At this point, I knew that I'm trying to oscillate my circuitry, and of course going through the fuses didn't help me any at all. And I said, okay, fine, let's go ahead and see from my, so this wire here goes straight to the this ground point here on the fender. Okay, let me see if this went back to sleep. Still 150 milliamps on this wire. Okay, and so I said, well, I have 1, 2, and 3 wires, ground wires, going out of this ground point here. So I took my clamp again and got over this wire, got 30 milliamps, pretty much nothing. I got to this wire, which this one is actually, I think, ground for new headlights. So I got on this one and got a 30 milliamps, pretty much nothing. And then I got to this wire here, and this cable here. I got around this cable. $190, 200 milliamps of draw. Okay, and we can pick it up 230, something like that. Okay, so I said, well, that is my cable, that is my circuit that draws the current. Now it's a ground wire. You can, it can be shaded with who knows how many different loads. So I said, well, I'm just going to start pulling this wire until I've, sees what's happening there. And then I've seen this fuse here, and then I just kind of following the wiring, and then came up to this relay, and sure enough, it was hot. Well, let's get the thermometer. And this relay was actually buried underneath the battery, and so with the thermometer, when I point my thermometer to one of the relays, it's like 85 degrees, and it's pretty much the same. It's actually outside temperature. All the fuses are 85, and then I go to this one. I'm reading 127 degrees. It fluctuates, but let's see this fuse here, if it reads anything. No, the fuse is fine, but this is my load right there. This relay is drawing the current. It's 130 degrees. Now let's go ahead and check the voltage drop across this fuse for this relay. So when I pull this off, alright, this is a 15 amp fuse, and so let's put the meter across the fuse and see what the drop is. 0.6 millivolts. Okay, so that's the absolutely indication that this is a live circuit. So the more current you're going to have in a circuit, the more of a voltage drop you're going to have. So 0.6 millivolts. Now when we are like, let's check the voltage drop from this point in a circuit to the battery positive. So what is the total voltage drop? 2.1 millivolts. So the voltage drops 2.1 millivolts from the battery post to this fuse. But if we measure all we measure is voltage drop right across these 2 points on the in a circuit, right on the fuse, and we see the 0.6, 0.5 millivolts. And and now we could probably measure the voltage. I'm not sure what's my control side of the relay, but we could probably measure the total voltage drop. Let's see here. Okay, so we are losing around 2.5. I'm not having a good contact here. Let's see. Okay, so we are losing 12 millivolts, 12.3 millivolts. That's our total voltage drop from the post all the way to the load, which is at this point my relay. And again, at each point in your circuit you're going to have a voltage drop in a live circuit. So again, the drop on our fuse here was 0.6 millivolts. Now the question is, of course, what's going on here? And so we need to figure out, you know, what is the if my relay is a problem, is it stuck, closed, or yeah, or is it let's just see, is it control side, is it load side, what is the causing issue here? Now here's my my adapter for the relay testing, and I got these wires soldered to this adapter, and I got the red and black, that is my load, that's my control side, and I got a green and blue, that's my load side of the circuit. So now I can actually check the, you know, quickly do a voltage measurements here. Let's see what the deal is. I'm gonna pull this relay out. It's actually pretty rusted out. This connector is pretty rusted out. So now let's go ahead and pull this guy in. Okay, so first what I want to do, without the relay, I want to check my control side to see if I'm actually having issue on the control side or the load side. If I see 12 volts on my control side, it means that something is shorted and relays has been energized. If that's okay, then it's most likely it's a relay stuck closed, and it's feeding some kind of component. And so let's go ahead and switch this to a higher voltage level, from millivolts to voltage scale, and we have 12.4 volts. So this tells me right here that it's not a relay problem, it is actually a circuit. The circuit is shorted and it's energized in the relay all the time. Now let's check the load side of the relay to see if we have any kind of voltage on the low side. On the load side, and on this leg I got nothing, and on this leg I've got nothing as well. So I'm looking at why. Maybe, you know, of course I might need to have a key in on position to whatever the power is getting to this relay. Maybe the key has to be on, or maybe car has to be running. You know, the engine needs to be running in order to supply the voltage on a load side of this relay. So let's go ahead and start the car. I'm just going to turn the key on so I have noise. Okay, so the key is on, and so again, my green and black, it's my load side. And again I got nothing. So it seems like this is some kind of ghost wiring that was left from previous headlights that were installed on this car, and this circuit does not have a load side, but we constantly have this power and ground applied to a control side of this relay. And let's see, as soon as I you know, you can see now you can hear the relay clicking, so you know it's energizing the relay. So what's actually drawing our battery is just a control side. It's just a coil inside of the relay is energized all the time, and that's around 150 milliamps of current, and it's enough for, you know, a couple of weeks, and it will eventually it will drain the battery all the way. And so that's how I was able to, you know, find this guy, how to find this problem, because he was about to lose my mind. You know, I'm looking through every single fuse, every single relay, and nothing was drawing, nothing was alive, but I could see that I'm definitely having a, you know, the current is going somewhere. And now I have to wait for the car to go to sleep. But you can see it's a big problem when you pull the fuse out. You know, it's possible that you're gonna wake up some of the modules, and then you've got to start doing all over again. But measuring a voltage drop across the fuse is by far the best, the less invasive, you know, way of finding the live circuit. So again, any open circuit has to be total zero on any open circuit. There cannot be any kind of a reading on your meter when you're checking the voltage drop across your fuse. It has to be complete zero. If there any reading on your meter, that's your live circuit, and then you have to investigate further. Now, something else would be difficult here. If they tap this circuit into, you know, they tap it somewhere. Actually, what they did, I'm sorry, I was just actually what they did. Actually, they just used this thick wire here, and it connected straight to the battery, and that's why everything was bypassed. You know, nothing was into the fuse boxes, and that's why it was so difficult to find. You know, that's the first step I do. Just go through the fuses and find your problem. And everything was bypassed, and I was like, it has to be somewhere, you know. And this is, you know, this is. And then I'm looking at the meter. Is my meter lying to me? And then I use a snap-on meter, and everything, you know, is still showing me a draw. And then I said, well, let's just go from wire to wire and see which one is alive. And so anyhow, that was the problem. Now, there's something else that could happen if they, and many times it happens as well, where whoever installed, you know, this aftermarket stuff, they can actually tap into the some fuse in a fuse box, and they would tap into some circuit, and then okay, you find a draw. Okay, that's the draw, that's the circuit, and then you go to wiring diagram and you look at the loads that are on that circuit and on the fuse, and you check each load and everything's fine, nothing is shorted, and then what? Because you have no clue that something else was actually tapped into that circuit. Luckily on this one went straight to the battery, and it's kind of weird that, you know, I'm not going to chase this setting further, you know, I don't need to. I'm just going to pull this fuse out, and because this relay here is just something that was left from previous, you know, repairs or whatever they done to it, and you can see there's absolutely nothing on my load side of the circuit. So this is just you know, relay that sits here for nothing, and it was, as I said, it was sitting all the way down at the bottom of this battery, and that's why I had such a hard time to find it. Anyhow, that's how I found this issue, and I'm just gonna take the relay out, pull the fuse out, and just leave it down, and it'll be okay, because again, it doesn't serve any purpose anyway. Okay guys, I hope you guys enjoyed this one, and this was a little tough. Of course, the video is somewhat short because I had to, you know, it was really difficult to oscillate this circuit. And alright guys, that's it. Thank you, see you next time. Bye bye.